Hi, welcome to today's YouTube video. In front of us, we have several of the most common electronics components. These are components that you'll also find around you in all sorts of, different devices, etc. But they're very, very common. And so we'll start with the most basic ones. So here we have a battery or a pair of batteries. These are your normal regular batteries that you'll find in remotes, in any sort of electronic device that's battery powered. These are AA sized batteries. The AA indicates the size of the battery. So you'll find like the smaller ones are called AAA, and then the big ones are called the D and etc. So different batteries have different sizes and designations. And then batteries go in battery holders. So this battery holder is essentially designed to put two batteries together so that they give one output. So a typical battery has a positive side and a negative side, and that will allow you to connect to one battery. However, if you want to connect two batteries, you're probably going to do something like this, so that now you have one long battery that has a positive and a negative, and this is giving you the combined output of both batteries, right? However, the battery holder allows you to put them together in a convenient way that then gives you the combined power that's coming out of this. And then we have a regular bulb, which basically gives out light. So this is an electronic device that converts electrical energy into light energy. We're going to see that shortly. And then we have wires. These are different types of wires, and all wires do is allow the movement of electrical current from one place to another. So wires connect electricity in circuits and allow it to flow. They're generally made of metal, so you can find that inside this wire there's like pieces of metal, copper, tin, iron, etc. And these are called jumper wires. On top of that, we have longer wires called crocodile clip wires that have a special thing at the end called crocodile clips that allow you to squeeze and open them. So this can then allow you to connect to something like that, right? So these wires, special crocodile clip wires. So what you might notice is that these two wires have different endings. So this one is convenient for connecting things, so you can connect these two together like this. However, this one has a special purpose that because it's designed to plug into something else, which we shall see shortly. That something is called a breadboard, which we shall see shortly. Put that aside. We have light emitting diodes. So these come in different colors, different sizes, but essentially they are a special type of bulb, just like the other bulb that we saw. The only difference is that these ones they give off colored light, but they also allow electricity to only move in one direction, and we shall see a demonstration of that shortly. But these are called light emitting diodes. We have resistors. Resistors also come in all sorts of different shapes and sizes. Some are big, some are small, some are really, really tiny, but generally resistors serve one purpose. They reduce the amount of electricity flowing in a circuit, and we shall see a demonstration of that shortly. We also have another electronic component called a switch. Now you have used a switch in many places. Every time you turn on the light, you're using a switch. Every time you turn on the kettle, there's probably a switch somewhere. When you're turning your phone on and off, you're pressing a button, and that button is a switch. So a switch, very, very simply, completes an electric circuit. So switches are very, very important electrical components, and we shall learn how to use them as well. This is called a breadboard. It is used for putting your circuit together in a very easy and very convenient way. So right now, we are going to make the simplest electronic circuit possible, which includes a battery, a bulb, and some wires, right? So this battery has a positive side and it has a negative side. The positive side and the negative side determines how the electrons flow in the circuit. If we put this here so that this end of the bulb is connected to the top of the battery. And then we connect a wire to this part. If we put it together like this, we should see this light up very dimly. So all that's happening is that there is electrical energy stored here being transferred through wires into a device that does something with the electrical energy. In this case, the something is that this device called a bulb converts electrical energy into light. So let's look at an illustration of what's happening with the electrical circuit we just saw. In an electric circuit, you have a battery that has a positive side and a negative side that looks like that. Right? And then you have a bulb that looks like that. When you connect a wire from this end and connect it here, and you connect another wire from this end and connect it here, you have completed an electric circuit. And then what happens is that now you have electricity flowing through this wire, entering the bulb, creating light coming out of the other end of the wire and going back inside here. So that's the very basic principle of how electrical circuits work, right? You have an energy source, which is a battery, and you have a device that converts that energy source into something. It can be converting it into motion, converting it into light, converting it into heat, converting it into sound. And as we go through this series, we will explore different devices that convert electrical energy into different things. But this is the most basic, all right? Let's take it a notch higher. So this is a battery holder. And the way that it works is that two batteries go inside and combine the power of the two batteries so that they are connected, their output through these two wires. So we just get these batteries, put them there. And now you have two batteries. And you're going to see the difference in the amount of light that's being given out between one battery and two batteries. So what we're going to do now is bring the bulb like that and like that. And now you'll see that it's much, much brighter because now it's combining the energy from both of those batteries and putting it into this bulb. So now we have a convenient way of holding the batteries, but we don't have a convenient way of holding the bulb. But I'm just going to improvise with crocodile clips, all right? And the other thing you need to know about wires is that as long as they are connected, the electrical the electrical energy will flow through them. So if I connect this wire that's coming from the battery, if I connect this, now the current will flow through this. You can just keep adding wires. Of course, there's a limit because you lose electrical energy. But if you keep it to just a few wires, you don't get a lot of losses. So in this case, I am just going to make it very convenient to hold this like that. All right. And then I'm going to connect this side to this side like that. So now it's very convenient that this bulb is sitting like that and this current is flowing. So if I just get that and put it there, we see electrical current flowing. So if I get this switch and connect a wire to one side of the switch, you notice that there are 2 points on the switch, 2 metallic points to the switch. So if I connect one wire to one side of the switch and then another wire, so now I have 2 of these connected to the switch. Now the thing you need to be very careful about electrical circuits is that you should never let 2 points from an energy source touch. So for example, we've seen here that this is coming from one side of the battery and this is coming from another side of the battery. You should never let them touch like this unless there's an electronic device in between them. This is called a short circuit. And this is what happens like when things blow in your house, or when like too much electricity comes into the house and things start blowing, or when you plug something in a socket and you see it exploding. That is because the electrical energy is too much, because there's nothing in between that is absorbing that electrical energy. So make sure that these two things are not touching each other. These two wires are not touching each other. And make sure they're also not touching each other from here. All right, so then we connect this to this. And then we put this here. All right, so there's no power flowing. But if I press this switch now, ta-da! Turn it off, and it goes off. So there's a lot of wires in here, but let's simplify it in a diagram. So this is what's happening in the circuit that we just looked at. You have a bulb that looks like that. And then you have two batteries. So in this case, we're going to draw two batteries. The positive side is connected to the positive side. Right? So you have positive of battery A connected to positive of battery B, and the negative is on that side. Then you have a wire that is coming like this, and one of those wires doesn't have a switch, so it's going straight to the bulb, but the other one has a switch. Right? So the symbol for a switch is that. So when this thing is open, there's like, if you try and see how electrical current will flow through, there is no opening. There is no space for it to go across because there is this gap. So at that point, the switch is off because it's not allowing electrical current to flow through. When you put it down like this, when you press it, what happens is that this goes like that. So now it creates a full circuit and you have your light. Once again, we have our batteries. This is going to be our energy source. Everything that's getting energy in this project is going to come from batteries. So we have our batteries connected together to combine the energy from them, coming out with two wires, and those two wires are now waiting to be converted into something else. Now, generally in electronics, electricity, the black wire comes from the negative side of the battery. And in most cases, in battery holders, it's represented by a spring. The red side normally comes from the positive side, which is normally just the thing with the top. Now, that may not always be the case, because if you don't have black or red wires, the color of the wire doesn't matter when it comes to transmitting electricity. It matters because it helps you identify which is which. But if you know what you're doing, you can use any color, and as long as you can remember. So in this case, we have a black wire that has been connected to another black wire to make it longer. But here we have a red wire that's now been connected to a white wire to make it longer. As long as we know that this red and white is representing the positive side, and this black and black is representing the negative side. So if we get the positive side and connect it to this copper side of the bulb, and we get the negative side and connect it to the bottom of the bulb, it will light as expected. What happens if we switch it around? If we get the negative side and connect it to the copper side, and the positive side connect it to the bottom, what happens? It will still light. So this bulb doesn't really care how you connect it. As long as it is getting electricity, it will display light. This is called non-polarized. That basically means whichever way you connect it, it will work. However, these bulbs, light emitting diodes, that also convert electrical energy into light, are polarized. If you connect it one way or another way, it will either light up or it won't. And that's because it allows electrical energy to only flow in one direction. Right? That's what polarized means. So let's look at a demonstration of that. If we get the negatives, the positive side, the red that's going to white, and connect it to this side of the LED, let's do it carefully. And then if we get the negative side, which is the black, and connect it to the other side, you'll see a small light. Now, I'm doing this for a very short period because this bulb is not meant to handle the amount of energy that's coming out of here. So that's why I'm just tapping lightly. And we shall learn how to limit energy in a few minutes. So that's lighting, all right? But if I switch it around, you're going to realize that nothing happens. There's no light coming out. And that is because this has a component inside it that will only allow electricity to flow if it's coming from one specific direction. That component is a very, very important electrical thing called a diode. And we shall learn about diodes later on. So this is called a light emitting diode. A light emitting diode is an electrical component that converts electrical energy into light. Emitting simply means giving out, right? Like when you have a rotten egg and it is smelling, it is emitting a bad smell. So this is a diode that emits light, that brings out light when you connect a electrical current to it. So the next thing we're going to learn about is called a breadboard. This is a very, very important component for connecting things easily. You remember how like we had so many wires all over the place? The more you keep adding, the more wires you'll need. However, a breadboard simplifies all of that, and it's designed in a very, very special way that allows you to connect circuits so that they don't interrupt with each other, but also make it very convenient. So breadboards come in all shapes and sizes. You can have the small ones that look like this. You can have the big ones that look like this, and there's some that get even bigger. And they also have these nice little hooks at the ends. You can see these at the end and also this at the top, which means you can stack. So you can add another breadboard that comes here, another breadboard that comes there, and just keep piling on depending on how big or complex your project gets. But they're really, really good for prototyping because of one simple reason. You can use jumper wires like this and just plug them in and connect. You can connect LEDs like this and just plug them in like that. So they're really good for holding electrical components together as you build and develop your electronic circuit. So let's take a very quick look at how breadboards work. A breadboard typically has three parts. You have this long section on the sides and on the other side as well. And then you have the middle sections that have a special kind of arrangement. So every single hole that you see in here is a point of connection for an electrical component or a wire. So you can get this wire and just plug it into this hole and it will be connected to something. Or you can grab this light emitting diode and plug it into this hole and it will be connected a certain way. So let's look at how the connections inside actually are designed. All right, so I'm going to draw how the breadboard looks inside, and then you just have to keep comparing what I'm drawing to what you're seeing. All right, if this is our breadboard, right? And then you have this line in the middle. Right? So this thick thing in the middle corresponds to this line in the middle. And then you have on the ends, you also have a small section here and another small section here. So this area here corresponds to this area here, and this area here corresponds to this area here, and then this middle area corresponds to this middle area. So we're going to see how the connections are inside the breadboard. Like when you plug this in here, how do you know where to plug in the next item so that it's connected to this? For the ones on the sides, you'll see that there are holes like that. Now, what you have to assume for these is that there is an invisible wire that is connecting this hole to this one, to this one, to this one, to this one. So all the holes on these sides are connected vertically. So this is also connected vertically like that. So if I get this wire and connect it here, which corresponds to this hole, you will have it connected to this hole as well, right? So these two wires are actually connected because there's an invisible wire that's connecting the one hole that's connected here to this other hole that's connected here, and that invisible wire looks like this. For the sections in the middle, they are connected horizontally. So these are connected vertically, these are connected horizontally. So you'll see that there's a hole here, 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 and here, 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 etc. So then what's happening is that this hole has an invisible wire running in there, 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 in there. So if we get this wire and connect it here, we have connected to this area, right? And if we get this wire and connect it here, we have connected it to this area on that same line. And that means that because there's an invisible wire going underneath it, these two are actually connected. It's as though there's one wire coming across like this and into the bottom and then coming out. However, if I get this wire and connect it to the lower row, then I am trying to connect this wire to this wire, and there's no physical connection in between. All right, so let's see this in action. And I promise you, if you understand this, you'll be able to prototype really complex projects. So I hope that makes sense. If you have any questions, please drop them in the comments. So the first thing that we're going to do is connect our batteries. So again, batteries are the power source that we're going to use to power all of our electronics projects. So we will get the positive side of the battery, like I mentioned, it comes from the red wire to the white wire, and the negative side comes from the black wire to the black wire. If you get a good breadboard, you will see that it has markings. The red is positive and the blue is negative. And what they're telling you is that if you connect this wire to anything on this negative, like we explained before, then you can connect anything else along that line and it will be automatically connected to the negative side of this. If you look closely, the negative side, which is the black wire, is coming from the battery and going into this row, this column of the breadboard that has a negative sign on it. Again, your breadboard may not have the negative sign, but as long as you understand how it works, you should be fine. And then we are going to get the positive side of the battery and connect it to the positive side of the breadboard. That's it. So now your battery, you don't need to connect anything fancy here anymore. As long as this is working well, anything you connect to this side will be connected to the positive end. Anything you connect to this side will be connected to the negative. And we can quickly demonstrate that by using our LED. So like I mentioned earlier, this battery is giving off a lot of electrical energy. So this LED won't be able to take it. So here's what I'm going to do, right? I'm going to remove this so that I can connect the LED and then connect it briefly, because as I'm doing this, I'm fidgeting around. So at this point, the LED is fixed in place, but it's not connected to the battery because I haven't connected this. So if I do this, that means I've connected it the wrong way. Again, LED has a diode, light emitting diode, which means that right now there's no current flowing through it because it's connected the wrong way. So again, I'm just going to remove this, turn my LED around, and then try the connection again. Again, very briefly, And now we see that. So you notice how that color looks almost yellow. And that's because there's a lot of electrical current flowing through the LED, which means that it's at very high risk of getting damaged. So I'll demonstrate that again one time. You see that, right? So that means you can see that the power is now flowing through the breadboard to get to the LED. So how do we reduce the amount of energy going into an electronic component? We use something called a resistor. A resistor, as we mentioned earlier, we showed you earlier, this is one of the most important elements that you'll find in electricity and electronics. They are everywhere. If you open power chargers, you'll find resistors. They're basically everywhere. And what resistors do is that they have a high resistance, meaning that they control the flow of electrical current so much. If you imagine water flowing through a pipe, right? Think of a resistor as someone's hand squeezing that pipe to control the flow of water. So let's look at an illustration. If you have a tank of water that looks like that. But what happens if you squeeze? If this is a plastic pipe that you can squeeze, what happens if you squeeze here? What's going to happen? The flow of water is going to reduce because now you have a much smaller area for water to flow through. So now this pipe becomes small like that because you have squeezed it. That means all your water now has to squeeze through this tiny hole and then come out. So if you squeeze it strong enough, you'll eventually stop the flow of all of the water. So if you think of this as the battery and this as your bulb or LED, right? The resistor that you put in here, you put a resistor here, is going to control the amount of water that's reaching your bulb. So the more resistance that you have here, the less water is going to flow out. So that means that you can use a resistor to precisely control how much electrical energy you want to flow in an electrical circuit. One other thing about resistors is that you're going to find that they have stripes on them, little different multicolored stripes. Those stripes represent the value of the resistor. They help you calculate it in precise terms, and we shall look at that probably at a later video, but not for this video. So for now, you can just ignore the values, but you might see that I'm going to demonstrate when one resistance is too strong and another is too weak. But just remember, the stripes on the resistor represents the strength of the resistor or how much electrical current it controls or stops. So again, with our breadboard, we are going to get the red wire going to the white wire. We connect it to the positive side of the breadboard from the battery. And then we get the negative side, put it on the negative side of the breadboard. And now we have power flowing through here. I'm going to do this demonstration one more time. Hopefully our LED doesn't die in the process. Again, to protect it, I'll just remove this, put it in there, test it, see if it's connected correctly. So now we are going to move this LED to this side because we don't want to connect it directly to this rail. We want to put a resistor in between. So I'll just put it like that. And what this means is that now anything that I connect here will be connected to this side of the LED. Anything that I connect here will be connected to that side of the LED. So we're going to get this jumper wire. Again, remember I mentioned that this wire is special because it has these little pins at the end that allow you to plug things in and out. Plug it in there and then plug it in there. So now I have electric energy flowing from this to that, all the way to that, coming through that, and then going into the breadboard all the way there and ending up here. But the other side is not yet complete. So the other side, we're going to put a resistor, and its job is simply to control the amount of electrical energy that's reaching this LED. So we'll connect it to this side, and then skip over to any other section here. Right, so now we have electrical energy flowing from the positive side, going into this wire, going into this area, coming into this other wire, dropping inside here, connecting here into the LED, flowing into the LED, coming to this side, flowing into the resistor, coming to this side, but the resistor is not connected to anything, right? So now we need to complete the circuit. To complete the circuit, we're going to get another jumper wire, connect it to one side of the resistor, and then simply connect it again to the other side of, now we're on the negative side of the battery. And if you do that, you're going to see that there's a very, very dim light. I don't know if you can see it. That's when it's not connected. That's when it's connected. So let me bring it closer so that you can see it properly. So right now there's nothing, but when I connect it, you'll see a very dim light. That means that this resistor here that we have used is too strong. It's reducing so much electrical energy that very little of it is reaching the LED. So we're going to change it to a slightly less strong resistor. So we'll just remove that and get another one with a different value. I know these values, so I know that this one will work, but eventually we'll learn about LED, we'll learn about resistors later. So I simply just replace it where I removed the other one from, and then complete the circuit. And this one is slightly brighter. So now that means that our LED is safe because we are essentially controlling the amount of energy. So I can leave this for as long as I want, the battery will run out, and I know that my LED will be safe. But if I had connected it directly by bypassing the resistor, this would be really bright and would eventually damage the LED. So it's basically absorbing all of the energy at this point and allowing very little to flow through. So our circuit devices are safe, our LED is safe. So I'm going to draw the visual representation of this circuit, but I'm not going to include the breadboard because there are too many connections inside there for me to draw. But I'm going to just simplify the circuit. But I'm going to just simplify the electrical circuit. So what you have is that you have your batteries. Two of them connected in the battery holder like that. Positive side, negative side connected to the positive side, negative side. And so what you have here is the negative side of both of them and the positive side of both of them. And so now here you have the negative, which is this. Actually, let's start from the positive side. You have this red wire going into the breadboard, coming all the way to the LED. All right, so you have all of that can be summarized like that. And then we have our LED. We'll just draw it like that. And then it goes there. So this is our LED. Right? And then now the negative side comes down and goes into the resistor. We call that a resistor. And then now comes back into the brown wire and comes all the way back here. So everything, all these wires are basically moving electricity from the batteries into the LED, into the resistor, and back into the batteries. So it's completing the circuit, allowing the flow of electrical current. So this LED can be here, it can be here. As long as it's one of its sides is connected to the resistor, everything is fine. In the next lesson, we'll be replacing this with actual electronic symbols. When you're drawing electrical circuits, this is not how you draw batteries, this is not how you draw LEDs, and we have different symbols that represent the different electronic components that we are looking at. Yeah, so that's a very, very quick overview of how to work with electronic circuits. You've learned about batteries, resistors, LEDs, breadboards, switches, different types of bulbs, and how to use these different wires. So in the next video, we'll be covering more electronic components. We'll probably dive a little bit into Arduino, which is really exciting. But if you have any feedback, any comments, any questions, please drop them in the comment section. So see you in the next video. Thanks for watching. Don't forget to like, subscribe, and share. See you next time. Bye.